On our last video, we discussed the three laws of motion. Let us state them one by one for us to recall the concepts. Law of inertia states that a body at rest remains at rest, or if in motion, remains in motion at constant velocity unless acted on by a net external force. Law of acceleration. The acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. Law of interaction. For every action, there is an equal but opposite reaction. Now, class, let us proceed to our new lesson. Enabling competency. Demonstrate how a body responds to changes in motion. Most essential learning competency. Infer that when a body exerts a force on another, an equal amount of force is exerted back on it. The lesson objectives are: identify the forces acting on an object at rest. Examine the conditions when two forces are balanced. Explain the effect of unbalanced forces on the state of motion of an object. And determine the net force that acts in an object. You learn that all objects fall because gravity pulls on them towards the center of the earth. Examine the pictures showing the pen and the flower vase. What makes the pen and the vase stay at rest? The pen stays in place because there is another force that acts on it. This is supplied by the string, which is referred in physics as tension force. Tension force is the force which is transmitted through a string, rope, or wire when it is pulled tight by forces acting at each end. The vase, on the other hand, stays at rest because of the upward push exerted on it by the table, which referred to as normal force. Both tension force and normal force counteract the pull of gravity that acts on the objects, which make them stay at rest. In both cases, you can now infer that the objects remained at rest because the forces acting on the pen and on the vase are: 1. Equal in magnitude. 2. Equal force but in opposite direction. And 3. They are in the same line of action. The forces are said to be balanced. What is balance force? Balance force are forces that are equal in magnitude and in opposite direction, so there will be no motion in an object. Here are some examples where you can see balance forces. Mango fruit hanging in the branch. Tension force exerted by the stalk is equal to the force exerted by the gravity. Thus, no motion is produced. Plate on the table. The upward force exerted by the table, known as normal force, is balanced with the force of gravity. Therefore, the plate is at rest. If you cut the string connected to the pen will fall. The pen falls down because there is no more force acting on it to counteract the pull of gravity. In other words, the forces acting on the object are no longer balanced. If an object initially at rest is under an unbalanced force, it moves in the direction of the unbalanced force. When we combine or add forces to determine the net or unbalanced force, let us recall the algebraic signs of positive and negative to indicate the direction of the forces. Unlike signs are used for forces acting in opposite directions, like in the case of the book lying on the table. The force of gravity and normal force are assigned opposite sides. Normal force is given a positive sign, while gravitational force is given a negative sign. If both gravitational force and normal force are given a magnitude value of 3 units, then the net force along this line will be net force is equal to normal force plus gravitational force. 3 units plus negative 3 units is equal to 0. If the sum of the forces equate to 0, they are considered balanced. If algebraic sum is not equal to 0, the forces are not balanced. The non-zero sum is the net or unbalanced force. This unbalanced or net force would cause a change in body state of motion. Let us go back again in activity 1. The vase on the top of the table. The vase stays at rest because it has a normal force of 5 units and gravitational force of 5 units as well. Using the Gressa method, let us find out what will be the net force of the vase. Given, normal force is equal to 5 units. Gravitational force is 5 units as well. Required, net force. Equation, net force is equal to normal force plus gravitational force. Solution, net force is equal to positive 5 units plus negative 5 units. Answer, 0. Therefore, there is no motion produced or the object is at rest. How about if the object is already in motion? How will the unbalanced force affect its motion? Place a ball on the desk, then push it gently to one side. Observe the motion of the ball as it rolls down the desk. What makes the ball stop rolling after some time? Again, you need to identify the forces acting on the ball. You see in this figure that the force of gravity and the normal force are again acting on the ball. But these forces are balanced, and so the ball stays on top of the desk. However, there is another force that acts on the ball along the horizontal line or along the force that set the ball in motion. Do you still remember your lesson on friction in lower grades? You learned that friction is a force that acts between surfaces that are in contact with another. Friction in general acts opposite the direction of the motion. In the case of the rolling ball, the frictional force acts between the surfaces of the ball and the desk and slows down the motion of the ball. Since you did not push the ball continuously, there is no force present to balance the force of the friction. So the ball slowed down and eventually stopped. Again, due to the unbalanced force, the object changes its state of motion. Hence, we say that it accelerates. Note that acceleration is not just an increase in velocity, but also a decrease in velocity. For you to measure your understanding about this lesson, please answer learning task 1 to 5 found on your module. See you on our next video for week number 3. Thank you very much and God bless.